All right, now let's check some more details about metric in EIGRP. In this example, you see kind of network that is, for example, one router from US, the next hop is Germany, and next hop is Turkey. When I use show IP EIGRP topology, in the topology table of the US router here, which here, you can see that it's learned this subnet, which belongs to the Turkey router from EIGRP. And this is interesting to here see. You're going to see FD, which we actually figure out that FD is represented as a metric of the best route. So here it says from US router to the Turkey router to this subnet, there are 3 successors. In fact, there are 3 routes to this subnet, and the metric of the best route is 2,809,856. So, and here you can see this number here I also represent. But the reason you see this different number is because here says this subnet on the US from 10.00.10. So 10.00.10, which is going to be the Germany router. And the reason you see different number is because I changed bandwidth here to the 1200. And that is why you see the different number. But here we can also get to the theory or concept of the unequal load balancing. In other words, even though you see different metric here or different FD, but still this path or this route is mentioned on a routing table, which is the exact example of the unequal load balancing. There isn't one exception that even though unequal load balancing doesn't work on EIGRP, and that would be the feasibility condition option, which is totally beyond the scope of this video, but that would be actually the CCNP concept. So here I just wrote the bandwidth of this links, and here you can see that based on the formula 10 to the power of 7, which is going to be 10 million divided by as minimum bandwidth. So EIGRP is going to pick the lowest bandwidth. So for example, if we want to use this path, so it's going to be pick this 1545 added to the sum of the delays. Each exit interface has a delay. When you use the command show interface and that mention that interface, that command is going to give you details about each interfaces. So by default, the serial interfaces has actually each serial interfaces on routers has a 20,000 delay. So we have one delay here, 20,000, one delay to this exit interfaces, 40,000, and here we have one loopback interfaces. By the default, loopback interfaces delay is 5,000. So 20,000, 20,000, 5,000, totally we need 45,000. And based on the formula, divided by 10, and finally we're going to be add these two part and multiply by 256 and finally we get 2,809,856 and 856 as the same number we get here. So this is one of the things that makes EIGRP as a very complex metric calculation, as you can see. Now let's go for the next slide. Here in OSPF, you can see that it's much easier and simple than the actually EIGRP, and which I can tell you that based on the formula here, for example, the same example on packet tracer from US to the Turkey, you can see that metric is here is based on the cost, and it's going to be 129 because each one of these interfaces is going to be cost 64, and loopback is by the default has a cost of the 1 for each interfaces, which totally get 129. 64 plus 1, we get 129. And very easy and simple formula. So I'm going to stop this recording, and in the next video I'm going to talk about the concept of the auto summarization and unequal load balancing more. Thank you.